project, you have a time that I can, yeah. Oh. So in this project, what we're trying to do is to create a pipeline to integrate different sequencing data in order to create a pseudo-WGS in a track from which we can extract variants. And so let me explain why we want to do that. Because we have a huge amount of data for many cell types, but we don't have the genotype information. So, and what we want to do is like to create, this resource integrating many tracks in order to provide, high quality variants called, and in order to characterize regions in the genome for which we don't have this information. And it is in particular relevant to study, for example, non-coding part of the genome, and there are like tons of data from the ENCODE project or epigenomic roadmap, for which we have ChIP-seq, RNA-seq, and many other assays that cover different parts. So you don't have enough power to code variants in the single assay. But if you integrate all the tracks, then you have enough coverage to reliably code the variants. The idea seems simple, but there are many, things that you have to do carefully. So we explored this idea, and we think we have now a pipeline that seems to work really well. So the goal is to make high-quality VCF file available to the community, mining all this public available data. We also created a website where the people can explore, any region in the genome and explore also the coverage that they get integrating multiple tracks. And also we will release a software pipeline. Right now we have just IPython notebooks and some scripts. It's not super clean, but everything is done. And in terms of the workflow, we focus on a cell line for which we have also benchmark data, and we'll see this in a minute. So we download data from ENCODE for this cell line, GM127A is a blood cell line, and then what we did was to think what are the steps that we need to do. We explored different softwares, but basically what we did was to start the reads, and we extract the coverage of single tracks and integrating multiple tracks. Then we did a base quality recalibration in order to use GATK and to reliably filter reads that are not good for variant holding. And finally, we have VCF file for different set of tracks, and then we did some benchmarking. So we have already a website. We will do a quick live demo. So yeah, David?
Yeah, so we wanted to show us off a website as a good way to do it. And so for the purposes of the hackathon with our time constraints, so we went with 5 different sources, mostly ChIP-seq datasets, to see how this idea worked in practice. And as you can see, so here's genes. This is whole genome sequencing coverage, and note that these are different scales, so 420x coverage, 4.1x coverage, and 51x coverage here. And so we go from WGS gold standard to doing this with 1 source and doing 5 sources. And here we have variant call from 1 source and variant call from 5 sources. We can see that, with a small fraction, like, 2% or so of the data that we'll eventually have, we're already seeing success, increasing multiplicative returns in combining these data sets together and calling variants, which is exciting.
And now we're generating the track with everything. It just takes some time, but...
Yeah, so now I'll talk a little bit about benchmarking. So we want to see how well this method actually performs. So to do this, we took high-quality variant calls from Genome and Waddle that uses all different sources of data, such as whole genome sequencing, exome sequencing, to get these calls in GM12878. So using this as a benchmark, we benchmarked using the 1 BAM file versus the group of 5 BAM files. So overall, we get an increase in precision, but we get a dramatic increase in recall. So it's over a 10-fold increase in recall just using 5 BAM files. So we hope by integrating hundreds of BAM files, we can increase this even more.
Yeah, with this I would like to thank the team. They were amazing, an amazing team. And I just want to say that I'm hiring computational postdocs. I just started the lab, 2 weeks ago. So I'm really excited. So if you know anyone or if you want to apply to my lab, we will do a lot of, things like this. And so, thank you.